Okay guys, so we're going to have a look at one of your required practicals here now, and this is all about Young's double slit interference experiment. Thomas Young came up with this experiment and we're going to have a look at it right now, showing the wave-like properties as a way of explaining what's about to happen. Okay. Now actually, if you look at the original materials that were used for this particular experiment, one of the things about it is, and I've actually been trying this at home, so I'm hoping in the next couple of days I'll have a video of me testing out this at home myself. He had a light source, okay, and that light source, he put a filter in front of it, a coloured filter. Now the coloured filter was to obviously absorb out the other wavelengths, so you've only got a single wavelength, okay. What he then did is he placed a single slit in front of it like so. He then had a distance of 0.5 meters to his double slit. Okay. Now none of this is to scale, none of this is exact, so just bear with the diagram, okay? And then what he had is he had a distance of 1 meter to a screen of some description. Okay. Now what he was able to show is if we look at it from a very sort of simplistic method of like so, and this is taken directly from the Kabuda book, is we get a pattern occurring like so, like so, and like so. And what this did is it created a pattern of dark and light fringes. Okay. And this is a way of us showing how a wave is essentially made up of tiny particles, but we're also able to show that the properties of reflection and refraction can come into play here. All right. So what we're going to be able to do is this really, if I show you really well and truly, is although reflection, refraction, all that's going to occur, the big thing that this demonstrates is interference. Okay, so that's the big thing being demonstrated here. All right. So let's have a look again and let's kind of try and delve into this a little bit deeper. Now, I'll give you the equation straight away. All right. So the equation is W equals the wavelength times D over S, where W is the fringe separation. Okay, lambda we already know. D is the distance from the double slit to the screen. Okay, and the last unit to consider here is S, which is the slit separation. Now, having a looked at a range of exam questions on this, the thing that you need to be aware of is quite often the wavelength appears in nanometers, okay, especially when we're dealing with visible light, and the slit separation tends to very much be in millimeters, possibly even micrometers. Right, so make sure that you can do all the conversions that you need to do. But in essence, this is Young's double slit experiment for interference. It draws on ideas of light being diffracted, reflection and refraction obviously are explained with other theories, and we're using a wave theory here. Okay guys, so really good. Hopefully you've been able to follow that really well. Any questions as ever, please do email me.